Does a frequency of 7.5 times 10 to the 14 hertz fall within the visible light region of the electromagnetic spectrum? And the electromagnetic spectrum is just simply light. Light has a constant speed, but there's some variability in there. And that variability is wavelength, the horizontal distance of the wave repeating itself. It's really big on the left side with radio waves, it's really small with gamma rays, and right in the middle is where we're trying to figure out where frequency lies. So, in that respect, we must find what wavelength is to figure out where it's going to fall. Is it going to fall under visible light, or is it not going to fall under visible light? And we're going to use this equation. C is equal to lambda times f. Propagation speed, wavelength, and f is frequency. We're going to take this equation and we're going to rearrange it to solve for the unknown. We know what propagation speed is. It's the speed of light, 2.998 times 10 to the 8 meters per second. And we also know the frequency because we were given that, 7.5 times 10 to the 14 hertz. But the problem is that these units are kind of all over the place. So in order to make everything work out, we're going to use this unit conversion, because 1 hertz is equal to 1 second's inverse. We plug all that in, use our calculator, and we get 4.0 times 10 to the negative 7 meters. We want to address that question, is this visible light? And we run into a little bit of a problem, because our calculation, our wavelength is in meters, but all of these values are in nanometers. So what that means is we have to do another conversion. We have to use the fact that 10 to the 9 nanometers is a single meter, and now we have converted our wavelength into nanometers. We get 400 nanometers violet light. So the answer is absolutely. Our frequency falls within the visible light region, and if you want, you can specify violet, and you might also want to specify not only what wavelength is, but give both answers, the SI unit of meters and nanometers.